Hello everyone, you're welcome to my YouTube channel, and today we'll be looking at differentiation by first principles. And what is actually differentiation? Differentiation is the process of taking derivatives. Okay, so you want to keep track, you want to know the change that has actually occurred, okay, over a particular period of time. The change from the final point, from the initial point rather, to the final point, right? That's what differentiation is about. So we want to look how we can differentiate functions by first principles. Okay, so those are the questions we'll be looking at for today. So for question number one, saying that y is equal to x squared plus 5, right? So our x squared here is the independent function, and our y is the dependent function, right? So to differentiate y is equal to x squared plus 5, that means we are looking for dy divide the x, that is change in x over change in y over change in x, or some persons can say y prime, right? Y prime written like this, right? Y prime. So that's what we are going to be looking out for. Okay, so for y equal to x squared plus 5, so the formula says that the y divide the x is equal to the limit as the x approaches 0 for f of x plus dx minus f of x divided by dx. Okay, let me use a good marker. Okay, so divided by dx. Yeah, so you could actually use your delta symbol, could actually use this, right? Yeah, and be mindful there is difference between this, the difference between this and this. So this is used for partial differentiation, while this is used for your total differentiation. Okay, so we are looking out for dy divide dx, right? Okay, so putting into the formula here, we have that dy divide dx is equal to the limit as dx approaches 0 for f of x plus dx minus f of x all over dx, right? So we have that dy divide dx will be equal to the limit as dx approaches 0. Okay, so we have f of x plus dx. So what we have there will be x plus the x squared plus 1, okay, plus 5 minus x squared plus 5 divide 2 divided by dx. So how did we get x plus the x squared plus 5? How did we get that? How did we come about that? It's your composite function, right? Function of a function. For example, if you're given that f of x is equal to 2x plus 3, right? And you're asked to find f of 3, you're asked to find f of 3. What it means is that everywhere you see x, you substitute it to put what? Yes, you substitute it to put 3. So this becomes 2 times 3 plus 3, and this gives you 9, right? So in the case where we have that f of x is equal to x squared plus 5, that's exactly what we have, because our f of x is the same thing as saying y equals to x squared plus 5, which is actually our question. And now the formula says f of x plus dx, so we are looking for f of x plus dx. What it means is that anywhere we see x in f of x, we will put what? X plus dx, right? So this becomes x plus dx squared plus 5, right? That was actually what happened there. So that's what we got. Okay, so moving on, this will be equal to the limit as the x approaches 0. Okay, so we have x plus the x squared. If you expand it, we'll get x squared plus 2 x dx plus the x squared, right? Then plus 5 now, plus 5 here, minus x squared minus 5 divided by the x. So divided by the x. Okay, divided by the x. Of course, we know how we are able to expand x plus the x squared. It's just like having two brackets and you open up those two brackets. Okay, so x squared minus x squared gives us 0. X squared minus x squared gives us 0. 5 minus 5 gives us 0. So what we are left with, the y divided the x is equal to 2x dx plus dx squared, right? That's what we are left with. The limit as dx approaches 0 for all over dx all over dx. Okay, so this is common denominators, right? The x is dividing 2x dx and the x is also dividing the x squared, right? So by that we'll get, this is the limit of the x approaches 0. So when we have 2x dx over dx, this cancels out, leaving us with only 2x. So we have 2x plus, here we have dx squared over dx. So dx will cancel out dx squared, leaving you with one of the dx, right? So we have plus dx. Okay, so whereas at this point limit of dx approaches 0, so this will now become 2x plus 0, which is equal to 2x. Therefore the derivative of x squared plus 5 is equal to 2x, and we've seen how we're able to get that from first principle, right? So we'll go over to looking at the derivative of other of the questions that we have. Okay, so I want to use this part of the board. So to the next question, we have that y is equal to 1 all over x, right? So the formula still remains the same, right? That the y divided the x is equal to the limit of the x approaches 0 for f of x plus dx minus f of x minus f of x divided by dx Okay, so we are going to be looking at for f of x plus dx. Our f of x, which is y, is equal to 1 over x, right? So divide the x will be equal to the limit as the x approaches 0. Okay, so we have 1 all over x plus dx. That means in place of x we are putting the x, right? That's what this place means, x plus dx, minus f of x. F of x is y, which is our original question. So minus 1 all over x. Okay, divided by dx. Okay, so at this point what we'll do here at the numerator is to clear the fraction, right? Is to resolve the fraction, simplify the fraction. By that, what we are going to get is that we'll get the y divided the x equals to the limit as the x approaches 0. So how to clear the fraction? Simply by using the butterfly method. Say for example you have half plus half, right? Simply you do this times this times this. So 2 times 1 is 2 plus 2 times 1 is 2, all over 2 times 2 is 4. So you're having 4 over 4, which is equal to 1. That means half plus half is equal to 1, right? So we just use that same approach to simplify the fraction. Same approach to simplify the fraction. Okay, so we have this times this divided by this. So by so doing, we have x times 1 is x minus x plus the x divided by x times x plus the x, right? So this is what we are having, yeah, divided by our dx, divided by our dx. And when you want to divide something, it's the same thing as multiplying by the inverse of that thing you want to divide with. The same thing as multiplying by the inverse of that thing you want to divide with, which is, so we can say this is times 1 all over the x, meaning that we are dividing by the x, this dx here, right? Okay, to simplifying, we have the x, divide the x is equal to the limit as the x approaches 0. Okay, so we have x minus x, which gives us 0, right? X minus x gives us 0, so we are left with minus the x. So this becomes minus the x all over x into x plus the x, right? Times 1 all over the x. Remember our limit as the x approaches 0, right? So this is what we have. So this can cancel out with this. Okay, so what are we left with? We are left with the limit as the x approaches 0 for this minus and this one gives us minus 1 all over x into x plus the x. Now remember, at this point, by substitution, the limit of the x approaches 0, so this becomes 0. So we are left with minus 1 all over x into x plus 0, which is minus 1 all over x squared. So therefore, by first principle, the derivative of 1 over x is equal to minus 1 all over the x, right? So we move down to the last, okay, to the last question. Okay, so for the last question, y is equal to the square root of x, right? And we are differentiating by first principle. So we have that by the formula that says divided by the x is equal to the limit of the x approaching 0 for f of x plus dx minus f of x divided by dx. So we are going to substitute straight. So what we are going to have is that we have the y divide the x is equal to the limit as dx approaches 0. Okay, so we have root of x plus dx, right? Anywhere you see x, you replace point where you see x, you put x plus dx, right? Because it says x plus dx. Then minus f of x, which is what we are working on, so which is root x divided by dx, divided by dx. So these are dx, right? Now, how are we going to tackle this? We'll be navigating through by rationalizing the numerator. So at this point, you see that it's possible to rationalize the numerator, not always about rationalizing the denominator, as we always see in the case of sword, right? So we want to rationalize the numerator, and it's the same principle as applied when you're rationalizing the denominator. All you have to do is to multiply by the conjugate, right? Okay, so we multiply here by the conjugate. So what we are going to have is the y divided the x is equal to the limit as dx approaches 0. Okay, so we have x plus dx minus root x times root x plus dx plus root x, okay, all over root x plus dx plus root x. Okay, so the conjugate is just the difference in the sign, right? The difference in the binary operation, and our binary operation here is addition, right? So here, this is also our dx. Okay, so by rationalizing the numerator, we multiply this by this, open up the fraction, the bracket. If we open up the bracket, we'll get something like dy, divide the x, of course, equal to the limit as dx approaches 0. Okay, so we have that square root of x plus dx multiplied by square root of x plus dx. We are going to get x plus dx, because for example square root of 2 times square root of 2 will give us 2, right? So the squares will just go out. Then we have that square root of x plus the x multiplied by this, so we have plus x into x plus the x, right? Again we have this multiplied by this, minus of square root of x multiplied by this, so we have minus of x into x plus the x plus the x. Okay, let me clean this part so we don't think they are together. So right, I'll have to trespass to this part of the board, and then finally we have minus root x times root x, so I have minus x, right, divided by dx into square root of x plus dx plus root x. Yeah, okay, so what's the next step? So the next step, this minus this will give us 0, because they are the same thing but difference in sign, so they will give us 0. So we are left with x plus the x minus x. So x minus x will give us 0, so we are left with only the x. So divide the x is equal to the limit as the x approaches 0, the x all divided by the x into root x plus the x plus root x, right? So, and we can see that this can cancel out with this, so we are left with the limit as the x approaches 0, 1 all over root x plus the x plus root x. What can you think of this at this point? Remember, limit of the x is approaching 0, so this becomes 0, so we are left with 1 all over root x plus root x. Yes, because x plus 0 is 0, so we are left with x plus x is x, so we are left with x here plus root x, and this is finally 1 all over 2 root x, and that's the final answer to our question. So by first principle, when we are deriving y equals to square root of x, our answer is 1 over 2 square root of x. And so we've come to the end of this video. I need you to like, subscribe, and share to your friends if you find this video interesting. Don't be so greedy to keep it to yourself. You can share it to your friends, and up until I come your way next time. Thank you.